Okay, let's continue. Session page 3. So from this, the time constant can be defined as the time taken for the voltage across the capacitor to rise to 0.6321 of its final steady value. Okay. Now the initial growth of the capacitor voltage would be voltage equals V over T equals V over C times R. Now again, I will repeat that voltage equals V over T equals V over C times R. And C times R, it gives you the constant. Okay, let us look at an example. A capacitor of 5 microfarads is to be charged in series with a 0.4 megohm resistor from a 100 volt supply. Okay, from a 100 volt supply. Okay, let me see if I can just highlight this for you to see it. Okay, okay, right, good. Okay. Now, here I'm asking you to calculate A, the time constant, B, the initial rate of growth of the capacitor voltage, C, the initial charging current, and D, the potential difference across the capacitor and the value of the current flowing through the resistor 4 seconds after the supply is switched on. Okay, so let's get this for you. Let's see if we can, it will allow me to highlight this all the way down. Yes, it has. Okay, so I can do that. Good, that's good. Okay. Okay, good. Okay. The next section is going to be section 4, page 4, I believe. Okay. I'm hoping that works. Okay, yes, it does. Now here we have, let's bring this up so we can see. Now remember, one thing is important. You have to write these out for yourselves. You cannot do this off the screen. Okay, you cannot learn this from the screen. You've got to actually write it, put pen to paper and do the calculation for yourself. Make sure that the calculations are done correctly and you know the values and what minus 10 to the minus 6 is, or 10 to the 6, etc. 10 to the minus 9, 10 to the minus 12. You need to be familiar with these configurations before you can proceed any further in this kind of calculations. Time constant, and remember it's A, so time constant here, let me see if I can highlight this for us. Oh, no, it won't give me any highlight. I've got to select a highlight. The highlight. Yeah, I think, let me try highlight. Try green. I'll stick with green highlights because, okay, let me see if I can get it on here. No. Peculiar. Okay, my highlighter isn't quite working. It's given from the initial stage. Will it give me? Yes, it will. Okay, let's try that then. Okay, let's see what it does. No, it's not doing it the way I wanted to do it. So let's just click him off. Okay, let's leave him as it is. We can leave it as it is. It's not coming up as I would like it to do. So that's what we're going to do. Okay, time constant T equals C times R. So 5 times 10 to the minus 6 times 0.4 times 10 to the 6. That equals to 2 seconds. Equal all 5 times 10 to the minus 6 times 400,000 equals 2 seconds. Okay. Now make sure you put this into your calculator as that 0.4 times 10 to the 6, because it is the value of the resistance that you're looking at. So that's the value of the capacitor, that's the value of the resistor. Okay. B, the initial rate of growth of capacitor voltage. Voltage equals V over C times R equals 100 over 5 times 10 to the minus 6 times 0.4 times 10 to the 6 equals 100 over 2 equals 50 volts per second. Now bear that in mind, it's volts per second, okay? Now here you have C, initial charging current I equals V over R equals 100 over 0.4 times 10 to the 6 equals 2.5 times 10 to the minus 4 equals 0.00025 amps, or equals 0.25 milliamps. Now again, check that this is what you get yourselves. Don't just take my calculations for it, because I could be totally wrong and having the foggiest idea what I'm talking about, okay? So make sure that in respect of the formulas that's been applied, that the calculations works out correctly. It is your job to make sure and check, check, check. Okay, I think that's about it actually for me on this one. Let me see if there's another 5. I could be wrong, but I don't think it's 5. Just check. Yes, there's 5. Okay. Yes. Goodness me. Thank you. Okay. Now, again, now here we have. Okay, that's good. We got him in place. Okay. Now here we have potential difference across capacitor. VC equals V open brackets 1 to the minus E to the minus T over CR. Now what you have is 100 open brackets. Here of course we close brackets. 1 open brackets 1 minus E to the minus 4 over 2. Divide the 4 by 2, and that gives us 101 equals 1 open brackets. My apologies, I'm going ahead of myself. Equals 100 open brackets 1 minus E to the minus 2. Okay. That's equal to 101 minus 1 over E plus 2. Now you're going to wonder why this becomes a plus. I'm going to leave that to you to find out. But you'll see, go back to your simple maths and your signs. Okay? Now this comes to equal 100 open bracket 1 minus 1 over 7.389. Okay. And you need to now remember, look at this bit here. How did we get from here to here? Now be aware of what process is implemented here. Okay, that big takes practice. Don't think you just know it by hand or it just occurs by magic. Okay, and again we come back to the value of E. Now again, remember, I could be totally wrong in my calculations here. So it's up to you to make sure that you're following the right process. So equal 100, open bracket 1 minus 0.1353 equal 100 0.8647. Okay. And that gives us 86.47 volts. And that would be the voltage potential difference across the capacitor in respect of that given time. Okay, so let's make sure we can get it all in. Okay, yes we can. Now follow this procedure. I've taken this a long way around. Some of you guys want to do it by magic. I'm not a magician, so I can't do it by magic, okay? Right, let's see the final question now. Okay, and here's our final question, question 6. Current flowing after 4 seconds. So I equals IE minus T over C times R equals 0.25 e to the minus 4 over 2. That brings us to 0.25 e to the minus 2. Now again, remember you're dividing 4 by 2, therefore it will give you 2 here. That is for you now to begin to apply that process. 0.25 times 1 over e to the plus 2. Yes. And here we have 0.25 times 1 over 7.389. And you've seen this before, okay? And 0.0338 milliamps. Now again, make sure that you have got the values correct, and it is milliamps. I could be totally wrong. I could be miscalculating it myself. I could be misreading my own calculations. So check, check, check. It is your responsibility to check, 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 and ensure it is correct. Okay, that will be it for now, I think. Thank you for your time. I hope you found this useful. Okay, have a good day. Bye-bye.